Hi, I'm Mr. Huber, and in this video we're going to talk about exercise 12C. Well, in exercise 12C we have a right-angled triangle, and we know the side length A, and we know the length of the angle bisector W beta. And what we want to work out is the median SA. That's what we want to work out. In order to do that, we're going to work out beta first, okay? Or to be more exact, we're going to work out beta halves first. This will be beta halves. Well, that's very easy because we do have a right-angled triangle, and I could finish it up here. This is a right-angled triangle. We know the hypotenuse. We know the adjacent side. So that means it's cosine beta halves adjacent A over the hypotenuse WB. So now we can plug in what we know. Cosine beta halves. So A is 15, W beta is 17. In order to work out beta halves, we need the inverse cosine. So beta halves is arc cosine 15 over 17. Or you could use cosine to the minus 1. So shift cosine to the minus 1, 15 divided by 17. Here we go. This is approximately 28.08. Beta halves is approximately 28.07. So beta is approximately 56.14 degrees. Here we go. So now we know beta. Well, look, if we knew B, then that would mean we can work out SA. Look, because we have another right-angled triangle here. And we know the length of this part, because this is just 7.5. Because this is the median, well in German, Seitenhalbierende or Schwerlinie. So that means this is the midpoint of the side A. Well, this is now 7.5 and this is 7.5 because the median halves the other side or goes through the vertex A and the midpoint of the opposite side. That's what the median is all about. That's a big difference, by the way, when compared to the angle bisector, okay? The angle bisector cuts the angle into two equal parts, but not the opposite side, okay? But the median does. The median goes through the vertex A and the midpoint of the opposite side. So if we knew the length of B, then we would be able to work in this red right-angled triangle, and we would be able to work out SA. So let's try and do that. Good. B, we know beta now, is sine beta is opposite over, no, not sine beta, tangent beta, I'm sorry. Look, tangent beta, because we know the opposite leg and the adjacent. So opposite B over adjacent A. We know beta, we know A, and we want to work out B. So tangent of 56.14 degrees, you use a stored value, if possible, b over 15. So you multiply everything by 15. So b is 15 times tangent of 56.14 degrees. When you do that, you're going to get b, that's approximately equal to 22.36 units of length. And now, once you know this, it's very, very easy, because now you can work out SA by using Pythagoras, because SA is now the square root of b squared plus a halves squared. So SA is 22.36 squared plus 7.5 squared, and the square root of it. And if you work this out, you're going to get 23.58 units of length. So a quick recap. We were given the length A, and we were given the length of the angle bisector W beta. That means we could work in this blue triangle. We worked out beta halves and then beta. With beta, we were able to work out b by using tangent beta is opposite over adjacent. We worked out b. Once we knew b, we looked at this red triangle, and well, this red triangle again is a right one. So that means this squared plus this squared is this squared. That's what we used, Pythagoras. And we were able to work out the length of the median. I hope everything's clear. See you in the next one.